5 into 10 to the power minus 5. This is C1 plus C2. Right?
Yes, sir.
And we can write it as, so let's keep this as 5 into 10 to the power minus. So you see that we have C1 plus C2. So we can use this information in here. Right? We can use this information in here. So what we will have? So this with C1, C2, this would be 5 into 10 to the power minus 5. And then this is 9 into 10 to the power minus 6. So this is how much? This is 9 5s are 45. And then 10 to the power minus 8. Right. So this is C1 into C2. Is it clear?
Yes, sir.
Now, how we can solve this problem? So to solve this problem, because these are very large numbers, so what we will do is that we will assume that we are calculating C1 and C2 in microfarad. Okay. So if C1 and C2 are in microfarad, so we can write this as 10 to the power minus 6, and this would be 50. So this is C1 plus C2. This is 50 into 10 to the power minus 6. And this would be in microfarad, right? So we can remove this 10 to the power minus 6. Right. So did you understand this logic?
Yes.
This was in farad, so we have written it in microfarad to make the calculation easy. And again, this is a 10 to the power minus 11, so we can write it as C1, C2. And then we have to write 10 to the power minus 12. So that would be 450 and 10 to the power minus 12. And then we can write it as C1, C2 in 450 microfarad square. Right. So this is the idea. Now, what we can do from here? We have C1 plus C2. We have C1 into C2. So what we can do? Have you done this kind of calculation before? Yes. If you have A plus B, if you have A into B, can you calculate something? There is an important identity. This text. There is an important identity. Solve this. So let me talk about that. So the identity is A plus B whole square. That is A square plus or A minus B whole square and plus 4. This is the identity. Do you remember this identity? Yes?
Yeah.
Yeah. So we have C1 plus C2, right? This is square equals to C1 minus C2 square plus 4 C1 into C2. So what would be this thing? C1 plus C2 square, that is 50 square, and then C1 minus C2 square, and plus 4 into C1 C2 is 450. So this is 2500. This is C1 minus C2 square, and this is 900. Right? So we can write C1 minus C2 square as 1600. So C1 minus C2 is simply 440. Right? And the answer is in microfarad. Right? Clear up to this point?
Yes, sir.
Now, how can we calculate C1 and C2? Can you tell me? How can we calculate C1 and C2 using these informations? This was a very lengthy question. Yes. Yeah. How can we calculate C1 and C2 from here? Linear equation, 10th standard, linear equation in two variables. If you have x minus y, if you have x plus y, then you can solve this equation to find x and y, right? So we have C1 plus C2. We have C1 minus C2. You can add these two. So by adding these two will cancel. So this is 2C1. This is 90. So C1 is 45 microfarad. And then C2 is, okay, oh, what did I do? And then C1 minus C2 is 40. So if I put C2, so that will be 5 microfarad. Right? Is this thing clear?
Yeah. Yes, sir.
So this would be the answer if we write it in powers, right? So what are the options that we have? So we don't have any options. First A. So first A option, why we have A option. So this, after simplifying, this would be 45 into 10 to the power minus 6. So we can write it as 4.5 into 10 to the power minus 5. Or we can write it 0.4 into 10 to the power minus 4. So these are the things that we can do. So do we have any 0.45? Yeah. So C2 is this one. So this would be, this is matching, but this is not. Total should be, total should be 8, 2, yeah, 2, 0.5. Okay, so I guess then we have done some mistake in calculation. Because you see in this one, right? You see, if we add these two, if we add, so there is some power mistake, right? So this is 5, 5s, and then this is 5 10 to the power minus 4. Yeah, you see this E option, right?
Yeah.
This A option, C1 plus C2, this is how much? 0.38 plus 0.12 into 10 to the power minus 4. So this is how much? This is 0.5 into 10 to the power minus 4. Right?
Yes.
This is C1 plus C2. And what we are getting? We are getting C1 plus C2, 5 into 10 to the power minus 5. So we can write it as 5 into 10 to the power minus 5. Right? If we take 1, if we multiply it by 10, divide it by 10. So 10 into 0.5, that is 5. And 10 minus 1, that is minus 5. So this C1 plus C2 is matching. Right? This is correct. And then what about the C1 into, so this is 1000. Right, this is 1000. And this is 9 into 0.45, right? So 9 into 10 to the power minus 6, that is also correct. 0.45. And then C1 plus C2, that is 5 into 10 to the power minus 5, so 45, and 10 to the power minus 7. So now we have to write it in 10 to the power minus 12. So we multiply 10, we divide 10, so this becomes 450 and 10 to the power minus 2. So this is also correct. C1 and C2 is also correct. What is 38 into 12? How much is this thing? So I guess there is 5, 6. Okay, so that is nearly 45. So yeah, then what is the problem? Okay, so this is correct. And then yeah, so 450 into, oh, this is yes. So there is the mistake, right? So this is the mistake that we have done. Did you understand the mistake?
Yeah. Yes.
Yeah, so this should be 4590 into, so this is 1800, right? So this is C1 minus C2 square, that is 700. Okay, and then what is the root of this thing? So the root of this thing is root of 700. So this is 10 to root 7. What is root 7? So 7. So 2.6 into 10. So 26.45. This is the correct answer. Now if we solve this thing, so this is 26.45. So let's write it as 26, right? Or 26.5, nearly, which is 26. So what would be the other thing? So 2C1 is how much? That is 76. So C1 is 38, right? Now what would be C2? So C2 would be 50 minus 38. So that is 12. So now our answer is correct, right? So C1 is 38 microfarad that we have taken. So 38 into 10 to the power minus 6 farad. So which means 0.38 into 10 to the power minus 4 farad. So this is C1, and C2 is similarly 0.12 into 10 to the power minus 4. So this is, so one mistake that we have done in here, and then we were getting it wrong. So this one is a very lengthy problem, right? This one is very lengthy, but yeah, this is important. This question is important. So now this is incorrect, right? This one we have calculated. Now, how can we calculate the charges on these two capacitors in the parallel combination? So we'll talk about that later. We'll talk about the second part later. But you do this first part. So please note it down, and if you have any doubt, please tell me. This is a very important question. Is it clear?
Yes, sir.
Yeah. So we just have to remember the energy And then the series combination capacitance, we put all those values, then this is a crucial part, the identity. So if we don't remember this one, then we cannot solve this. So we have to just remember this, right? Yeah, so please note down this one and then we'll do the second part of this question. Please note it down. Yeah, whenever you want me to scroll down the screen, please tell me.
Yes, sir.
And please practice these questions, right? So as you saw that I did some mistake in the calculation. So yeah, you have to practice to get rid of these problems. Yeah, whenever you want me to scroll down the screen, please.
Please scroll, sir. Done, sir.
Yeah. Okay, so now what we have solved. Okay, so in the second part of this question, what they're saying is that in the parallel combination, what we have to calculate. So we have C1, which is 0.38 into 10 to the power minus 4. And then we have C2, which is 0.12 into 10 to the power minus. And then this is in Farad. So uh, calculate the charge on each capacitor in parallel combination. So we have to calculate the charge on each capacitor, right, in the parallel combination. So we have to calculate the charge, right? Let's say Q1 and Q. So how can we calculate the charge? Can you tell? How can we calculate? Because we have done numerous questions of these kinds, numerous questions. How can we calculate the charge? Yeah, what are the given informations that we have? This is 100, right? So this would be also 100 volt. This would be also 100, right? You have C2, you have C1. So you can calculate Q1 as C1 V. You can calculate Q2 as C2V. So C1 is how much? 0.38 into 10 to the power minus 4. And then V is 100. So this is 0.38 into 10 to the power minus 2. Similarly, this is 0.12 into 10 to the power minus 4 into 100. So 0.12 into 10 to the power minus 2 coulomb. Right, that is the answer. Is it clear? Why did you get confused?
Yes, sir.
Yeah, so this was the next part. Please note it down and then we will do the second question. Yeah, whenever you have noted, please tell.
Mansur.
Done. Okay, so
Yeah.
then let us do the next question. This was not a sharing of capacitors question, right? But this was important. So the next question is a capacitor of capacitance 6 microfarad is charged to a potential of 150 volt, right? And then its potential falls to 90 volt when another capacitor is connected to it. Find the capacitance of the second capacitor and the amount of energy lost due to the connection, right? So initial case is what? Initial case is, so we have a 50 volt supply, and then this capacitance is 6 microfarad. Right, so we can calculate the charge, initial charge. How much is that? That is C into V. So that is 150 into 6 into 10 to the power minus 6. Right, so this is how much? 6, 90, 900, and then 10 to the power minus 6, which is 9 into 10 to the power minus 4. So this is the initial charge, right? Now, second case is that you have you are connecting this capacitor to another capacitor, right? And these are in parallel connection. So this is positive, this is negative, and this is uncharged, right? So then it will get some charge, and now the voltage has become, so this contains the voltage which is 90 volt, and this is also 90, right?
Yes.
Now this is a parallel combination, right? So we know that the charge, whatever the charge was here, so that should be conserved. So Q final would be how much? That is this combination Q C effective or C equivalent into this voltage. So that is C1 plus C2 into 90. This is Q final, right? Right.
Yes.
So now from conservation of charge, because charge should be conserved, right? Conservation of charge. We have Q initial that is equal to Q final. So this is 9 into 10 to the power minus 4. This is C1 plus C2. So C1 is given 6 and plus C, right? And then into 90. So this would be how much? 6 plus C. This would be 9 into 10 to the power minus 4 divided by 9 into 10. So 9 cancels. And this is, oh, so this is 6 microfarad, right? I should write microfarad. So then this is 6 microfarad plus C, and then this is 10 to the power minus 5. So to write it in terms of microfarad, I have to multiply 10 divided by 10. So this would be, this is 10 microfarad, right? So C would be 10 minus 6. So that is 4 microfarad. So that is the unknown capacitance. Is it clear to you?
Yes.
Okay, now they are asking that the amount of energy lost due to the connection. So we have to also find out the energy lost, right? So first note down this part and then we'll do the next part. Please note it down. But we already know the answer. The answer should be this one, right? Because this is 4 microfarad, so this should be this. Yeah, please note down this. Yeah, whenever you have note it down. Yes, whenever you have note it, please say.
Please go.
So you have to keep track of this notation, right? Whether we are using microfarad or farad.
Yeah.
So this is
Done.
right. Done. Okay, so now we have 4 microfarad and 6 microfarad, right? Two capacities that we know. And we have to find out the loss in energy, right? Energy lost, we have to find out. So initial case is this one, right? The initial case is that you have this 150 volt thing, and then you have 6 microfarad. So what is the energy of this thing? Half CV square, right? So half and 6 microfarad, and then V square, that is 150 into 150. So, okay, so this is 3. And then we have 45 into 15. How much is that? Okay, so 45 into 15, and then 10 to the power minus 5. So how much is not minus 5, but minus 4. Right. So this is how much? 15 5s are 75, 60, and then 7, so 675 into 10 to the power minus 4. So 6.75 into 10 to the power minus 2. This much joules, right? This is the initial energy. Now we have the final case in which we have two capacitors. This one is 6 microfarad, and this one is 4 microfarad. This one has voltage 90. This one has voltage 9, right? So for this one, the energy is how much? Let's say U final 1. So half CV square, right? And then U final 2 is half C, let's say C1 V square, C2 V square. So U final is U final 1 plus U final 2. So half C1 V square plus half C2 V square. So this would be U final would be half C1 plus C2 and V square. Right, so this is how much? This is half. This is 6 plus 2, that is 10 microfarad into 15 into, not 15, but 90 into 2. Right, so how much is this thing? This is 5. And then 9 nines are 81, 81 into 5. So 5 is 40, so 405. 405 into 10 to the power, this is minus 6. So 10 to the power minus 6, and then we have 2. So that is 10 to the power minus 4. So this one would be how much? So if I write it in terms of, yeah, so this would be how much? So this is 4.05 into 10 to the power minus 2. Right. This is the final energy. So what is the loss of energy? That is U initial minus U final, which is delta U. So delta U is 6.75 into 10 to the power minus 2. And then minus 4.05 into 10 to the power minus 2. So this is 0. This is 7. This is 2 into 10 to the power minus 2. So if we take this minus 2 the other side, so this would be 0.027 joules. So that is the loss of energy, right, which is there. Is it clear to you?
Yes.
Okay, please note this one. Please note it down. So the only thing that we have to do is practice all of these questions, right? There are lots of calculation involved. So yeah, we have to practice to do all the calculation correct. Yeah, whenever you have put it down, please.
Yes, we're done.
Okay, so the last question I will leave it to you, right? This is then it is connected to another uncharged six. So this is same, right? You have to find out a loss of energy. So same thing that we have to do, right? They have already given you the capacitance. Now this time you don't have to calculate the capacitance, right? So this question you try at your home. And if you have any problem, then we can discuss this. Okay, so yeah, this was all about the capacitance, right? Oh, then we have the sharing of conductors as well, right? So let us do this last question, and then this chapter will be completed. We have half an hour. Right? So now we were talking about the sharing of capacitors. Now we are talking about the sharing of conductors. So in these type of question, this one is very important one. So there are two charge conductors, right? And they are connected by wire. And let's say it has some distribution and it has some distribution. So due to different distribution and different potentials, this one will have different potential, V1, and this one will have different potential. So due to a difference in potential, there would be some transfer of charges, and this would happen until both the potentials becomes the same, right? If they are connected. If they are connected, so in final case, at equilibrium, both the potentials will become same. That is the idea, right? So now we have to find out the ratio of the electric field. Let's say this is 1 and this is 2. So this is a conductor, right? And do you remember what is the potential for a conductor at the surface? We are talking about at the surface, right? At the surface of two spheres. So we are talking about at the surface. What is the potential of the sphere at the surface? Yes. If you have a conducting sphere, preliminary information that you should have that if we have a sphere and this is a conducting sphere, so in conducting sphere, all the charges reside on the surface, right? So if we have a conducting sphere, then how the potential varies? That is the second topic of this chapter, right? So you have already calculated this electric potential of the sphere. The variation is like this, right? So this is this and this one. So up to this one, this is inside, this is surface, this is outside. So if you are calculating the potential at outside point, let's say in here at r distance, so this will vary as 1 over r. So this is potential is k cubed by r, right? Outside. Inside and let's say this radius is r. So inside and at surface, this is k cubed by r. This is constant. So up to surface, potential is constant, but it decreases outside. So that is the variation, right? Do you remember this thing? Yes. This you have done already, right? Yeah. So we have used the same thing, right? So we are calculating this is the R equal to R surface. This is the R variation. This is the V variation. So When R becomes R, this is the point. And then, yeah, so what is the sphere? So sphere is like this, right? So this is R equal to R, and then this changes, right? So, okay, so V1, what would be the potential at the first surface? So that would be KQ1 divided by. Similarly, V2 would be how much? That would be KQ2 divided by V. So KK cancels and Q1 by Q2, this would be A by V. This is what we get from this condition. Is it clear? Yeah, I can explain this thing again if you say so. So is this thing clear to you? Did you understand this thing? Yes? Did you understand this part? So we are calculating the potential at the surface. Radius is A. In here, the radius is capital R. In here, the radius is A. So potential would be KQ by A. Right. In here, the potential would be KQ by B. So we got the ratio of the charges. That is what we have done. But this should be known. Right. This is the thing that we should know before. Okay, clear. Is it clear? Now in the question, they are asking what is the electric fields at the surface of the sphere. Right. So can you tell me what is the electric field of the sphere at the surface? What is the electric field at the surface? Electric field at the surface. That is KQ by R square. Right. So electric field E1, that would be KQ1 by A square, and E2 would be KQ2 by B square. So if we divide E1 by E2, this would be KQ1 by A square divided by KQ2 by B square. So this will cancel, and this would be Q1 by Q2, and this B square will go upstairs, and this would be Q square. So Q1 by Q2 we have already calculated, so we put this value. This is A by B into B square by A square. So A cancels, B cancels, and this is B by. So this is the ratio. Okay, is it clear? Yeah, if it is clear, then please note it down. So that will complete this chapter. Please note it down, and then we'll start the next. We'll start the next step. If you have any doubt, you can ask. Whenever you have noted, please do.
Done.
Okay, so now let us let us start the next chapter, which is electric current. Okay, so now let us so the first thing that you have the first thing that you have learned in the third chapter, and that is the definition of current, right? Right, right, Khadeeja.
Yes.
So, what is current? What is current? So, current is simply the rate of flow of charge. Right. If this charge is fixed, if this charge is same amount of charge is flowing in same interval of time, then this current is called the steady current. But let's say that this charge is variable. Right. This charge is variable. This is some function of time. So this is changing with time. In that case, you have two kinds of current. One current is the average current, and then the other one is this instantaneous current. Right, so average current is what? I average is delta Q by delta T. And instantaneous current, this is also denoted, shorthand notation is I, dq by dt. Right, so these are the currents that we have studied, right? Right, these are the things that you have studied, right? Yes. Yes, can you hear me?
Yes.
Yeah, so then, and then you have studied about the graphical interpretation. So what is the graphical interpretation? That we can have two kinds of graph, right? One is the charge time graph, and the other one is current time, right? So if we have a charge time graph, right? If we have charge time graph, let's say we have charge and time graph, and let's say this is the current. So then the slope of this graph, right? Let's say delta Q by delta T. So slope of QT graph will be current, or to be precise, average current. So I is delta Q by delta T. So whenever you have a charge time graph, you calculate the slope, and then you will get then you will get this current. And this is also equal to tan theta. So tan theta is current, which is delta Q by dt. So this is the charge time graph. If you have current time graph, if you have current time graph, let's say this is the kind of graph that you have. So in the current time graph, the area under the graph, that is given by the total charge. Right, so this is the area. So area under IT graph gives charge. So this is the important points to remember. If you have current time graph, area under graph will give you charge. If you have charge time graph, slope will give you the current. These are the two aspects of the graph, and then you have these three kinds of current. So these things you have already studied, right? Right, do you remember it now? Do you remember all these things? Yeah, so now let us do all those calculations. How much time do we have? So we have 50 minutes. So let us talk about, or let us solve these questions. Okay, so the first question, right? First question says that in a hydrogen atom, right? In a hydrogen atom, what do we have? An electron moves in an orbit of radius 5 into this meter. So we have a hydrogen atom. Proton is in the nucleus, and then this electron is revolving around this circular orb. Right. So this is the electron that we have. This is moving. Electron is moving. So due to the electron movement, there would be some equivalent current. Right. And we have to find out that equivalent current. So that current would simply be charge divided by time. Charge is this electron is moving, so E divided by time. So the thing that we require is this time, right? This is the time that we require. Okay. So can you tell me how can we calculate this time? How can we calculate this time? Yes, how can we calculate this time?
T by I.
T by, yes, T by time we have to
By I.
calculate. Yes,
Q by I.
Q by I. Okay, but we have to calculate this current. In this question, we have to find out the current. Right, this current we have to find out, and to find out this current, we have to find out this times. This is moving in circular orbit, so we can calculate one orbit distance, right? And that distance would be 2 pi r, right? And speed is how much? Speed is v. So we can calculate the time as distance by speed, right? Right, so this would be 2 pi r by v. This is the time. Right, is it clear?
Yes.
So the time would be 2 pi r by v. So now we have got the time. Now we can calculate this current. So current would be E by 2 pi r by v. So E into V divided by 2 pi r. So this is 1.6 into 10 to the power minus 19. Velocity is or speed is 2.2 into 10 to the power 6. And then 2 pi is 22 by 7. And then we have 5 into 10 to the power minus 7. So these are the things that we have. So this 7 goes upstairs. And this is 1.6. And if we remove this thing, so this is 10, right? 5 twos are 10. So, and then we can cancel this 20. So this is 1.6. And then we have 10 to the power minus 19 into 10 to the power 6. And in the denominator, there is 7 also. And in this denominator, we have 5 twos are 10 into 10. And then 10 to the power minus 7. So we have 17, say 6 are how much? 2 and then 7 1 7 and 4 11. So 11.2 into 10 to the power minus 90 plus 6. This is plus 11 and minus 2. So how much is this thing? And then we have 10 to the power minus 19 and minus 21 plus 17. So this is 11.2 into 10 to the power minus 4. So we can write it as 1.12 into 10 to the power minus 3 meter. Not meter, but this is current, so amperage. Right. Is this question clear to you? Is this question clear?
Yes, sir.
Please note this one down. Yeah, so we have 10 minutes, so we can solve the next question also.